Hello. In this lesson, we're actually going to apply what we did in the last lesson directly. So throughout this unit, we've been investigating polynomials, kind of our new tool in our math toolbox. Similar to when you were first learning numbers in elementary school or fractions in middle school, the first thing you look at is how can you add, subtract, multiply, and divide them, and that's what we spent our time doing so far. How do I add and subtract them? Well, I add and subtract like terms. How do I multiply these things? We do something called multiple distribution, or some of you make a table to organize it. And then how do I start to divide? Well, we do something called factoring. Today we're going to look at how can I start to solve equations that have quadratics, so a power of 2. And we're going to start by doing probably the worst method, but we're going to give it a try so we appreciate our newer and faster technique. But the first thing you could maybe ever do is guess and check. So I'm going to challenge you. By guessing and checking, I would like you to find as many values for x that you can that make the left side equal 0. If you think you found one, see if you can find more. So pause the video now, maybe let's give 2 minutes. In 2 minutes, see if you can find as many values for x that you can put in for x and make the left side equal to the right side, so make the left side equal to 0. So pause the video now, unpause it once you've had a chance to try. Okay, welcome back. Maybe you found one, maybe you found two. You shouldn't have found more than two because it turns out there are only two for this one. Actually, the power tells you how many answers you should expect to get when we were solving lines back in the first part of the year. An example might be 7x plus 10 equals 0. Equals 0. I would subtract 10 and then divide by 7, I get negative 10 sevenths. Only one answer because the power is 1. This one, the power is 2, so I should only expect actually there to be 2 answers. You'll look at the formal theorem for that in later math classes. Turns out the 2 answers for this are x equals 6 and x equals 9. And so we're going to see why those are the answers here in a little bit. I'll come back to this and share with you what's a quick way to get 9 and 6. So let's do the lead-in. So here we go. Here's the lead-in idea that's going to make the problem we just solved much easier to answer than just simply guessing and checking. So imagine I have 3 items that are multiplying each other. Call them red, blue, and green. And I know that they equal 0. But now I'm going to tell you something about red. Red is actually equal to 2. Blue is actually equal to 3. And I don't know what z is. But I do know when they multiply each other, they equal 0. Well, if I have a long chain of multiplication, one of them needs to be 0, and I already know it can't be x and it can't be y, so that means z has to be equal to 0. If you have a long chain of multiplication, something in that chain has to be 0, at least one, maybe more than one, but at least something. And if it's not x and y, it has to be z, because 2 times 3 times 0 is the only way to make 0, if the first parts are 2 and 3. Now let's try it with, instead of having just single variables, we have an expression. So again, I've got maybe red thing times blue thing equals 0, but I know the blue thing is equal to 3, which means the red thing has to be equal to 0, because I have red times blue equals 0. One of them has to be 0. What's the value for x that would make the blue thing be 0? X would have to be negative 2. If x were negative 2, then negative 2 plus 2 would make 0, and 0 times 3 would be 0. So in this case, x would have to be negative 2. Now what if I have 2 variable statements? Again, the game's the same. Red times blue equals 0. If I have 2 items and I'm multiplying them, one of them has to be 0. What would make the red thing be 0? The red thing would be 0 if x equaled negative 5. If x were equal to negative 5 and I put it back in, what would happen? Well, I would get negative 5 plus 5 and negative 5 minus 3. Negative 5 plus 5 is 0. Negative 5 minus 3 is negative 8, and 0 times negative 8 makes 0. So it works. What if it was the blue thing, though? Maybe it wasn't the red thing that was 0. Maybe the blue thing was. If it was the blue thing that was equal to 0, then x equals 3 would do the job. Let's check. If I put 3 back in for x, 3 plus 5 times 3 minus 3. 3 plus 5 is 8, and 8 times 0 is still 0. So that works. So either x equals negative 5 or x equals 3. And this last one is going to be the clue to how we could do that warm-up quicker. So when I was thinking the x plus 3 and the x minus 5 equals 0, what I was using is a special property. We call it the zero product property. What it says is if I have 2 items, 2 numbers, 2 items that I'm multiplying and they equal 0, if I have red thing times blue thing equals 0, then I know either the red thing or the blue thing has to be equal to 0. It's the only way it will work. And actually, 0 is a very special number. It's the only number that this is really ever going to work for. Here's an example. What if I told you if A times B equaled 20, is it guaranteed that A or B has to be 20? No. For example, A could be 2 and B could be 10. A could be 40 and B could be a half. There's literally an infinite amount of possibilities that I could come up with. But once I tell you A times B equals 0, it's guaranteed that either A or B is equal to 0. 0 is the only number that that property works for. That's why it has its own special name. It's the zero product property. It's what allows me to actually solve when items are factored. So let's say I have x plus 3 times x minus 5 equals 0. I essentially have red thing times blue thing equals 0. I know one of those things has to be 0. Let's look at what the red thing is. The red thing is x plus 3. If that was the thing that was equal to 0, what would x have to be? Well, x would have to be equal to a negative 3. But maybe it's not the red thing that's equal to 0, so let's not worry about it. Maybe it was the blue thing that was equal to 0. What would x have to be to make the blue thing equal to 0? Well, x would have to be a positive 5. If x were equal to a positive 5, then 5 minus 5 would make 0, and it wouldn't even matter what the red thing is, even though it's 8, because 8 times 0 would make 0. So there's my two answers. Either x has to be negative 3, or x would have to be 5 in order to make 0. Let's try a few more. Just kind of go through these quickly. Just applying my zero product property. First one, x plus 14 times x minus 3. Again, it's just red thing times blue thing equals 0. What would make the red thing be 0? Well, that would be if x equaled negative 14, because negative 14 plus 14 would make 0. What if it was the blue thing? Well, the blue thing would be 0 if x equaled 3. If I had x equal 3, I'd have 17 times 0, but that's still 0. So there's my two answers for that one. Move over to the second. Again, red thing times blue thing equals 0. What if it was the red thing that was 0? If it was the red thing, then m would have to be a 12. What if it was the blue thing? Well, then m would have to be a negative 5. And there's my two answers. Either m is 12 or m is negative 5. Last ones. I won't use the boxes. I think you get the idea. If it was the red thing that was equal to 0, either p is negative 15. If it was the blue thing, then or p is negative 24. P has to be one of those two values because either the red or the blue has to be 0 in order for the statement to multiply two items and make 0. So if it's factored, these are pretty easy questions. What about one like this though? So I can't just look at it. I'm actually going to have to solve it. So let's go back to our core concept. Red thing times blue thing equals 0, our zero product property. Let's say it was the red thing that was equal to 0. So maybe I know 2x minus 1 equals 0. Well, then I just solve. This is from like back in September. Add 1, I get 2x equals 1. Divide by 2, I get x equals a half. So there's one of my answers. Now, maybe it wasn't the red thing that was 0. Maybe it was the blue thing. If it was the blue thing that was equal to 0, then I know 3x minus 1 would have to equal 0. Add 1 to get my numbers to the same side. Divide by 3 to solve. And I get 1/3. So either x is equal to a half to make the first thing be 0, or x is equal to 1/3 to make the second thing be 0 in order for one of these to be 0, and therefore when I multiply them, the product is equal to 0. I'm going to give you a chance to try. You try these two. What would y have to be in order to multiply these two binomials and make 0? So pause the video now for maybe a minute, should probably be enough time. Unpause it once you've had a chance to try and want to see what the answer is. Okay, real quick, again, zero product property. Red thing times blue thing equals 0. What would make the red thing be 0? The red thing would be 0 if y equaled 3. What would happen if the blue thing was 0? Well, if the blue thing was 0, we need to solve a little bit. I know 5y plus 10 would have to equal 0. Subtract 10 to get my numbers to the same side. Divide by 5 and I get negative 2. So either negative 2 or 3 is going to be my solutions. So as you can see, these are pretty quick and easy if it's factored. What if it's not factored? So if I want to know x squared plus 3x plus 2 equals 0, well, what do I need to do? I need to make it look factored like we did before. So I need to factor it first. That's why we practiced factoring in the prior sections. I need to find two numbers that multiply to be 2 and add up to be 3. Then finding the solutions will be really quick. What two numbers multiply to be a positive 2 and add up to be a 3? Well, it's going to be x plus 1 and x plus 2. 1 times 2 is 2, 1 plus 2 is 3. And now once it's factored, it's straightforward to solve. It's just what we were doing a second ago. Red thing times blue thing equals 0. What would make the red thing be 0? Well, if x equaled to -1. So one of my answers is -1. My other answer would be, what if it was the blue thing that was 0? It would be x equals -2. So my two answers are -1 and -2. Be aware, a mistake a lot of people start to make here is they start to say that the answers are x equals 1 and x equals 2. No, the factors are x plus 1 and x plus 2. The factors are just the step that allows me to easily get to the answers. If the factors are x plus 1 and x plus 2, my answers or my solutions have to make the factors be 0. So -1 and -2 are my answers. This is the clue to how you could do the warm-up one quicker. So if I go back to that warm-up question, if I factored it and I found two numbers that multiply to be 54 and add up to be -15, well, the two factors, so they have to multiply to be a positive and add up to be a negative. Well, that has to be two negative numbers. That's the only way they're going to multiply to be a positive and add up to be a negative. And it's going to be -9 and -6 are the factors, which means the solutions are +9 and +6. And there they were from guess and check, but factoring is much quicker. What if I don't have it equal to 0 like this one? I have x squared minus 5x equals 24. Well, we need it equal to 0 because 0 is the only number that little trick, it's more of a clever idea than a trick, works for. So how do I make this side equal to 0? I subtract 24 from each side. So move the 24 over the other side by subtraction. So subtract 24 from each side. 24 minus 24 to make 0 here. Now I factor it. I need two numbers that multiply to make -24 and add up to be -5. If they multiply to make a negative, they have to be opposite in sign. If they add up to be a negative, the bigger number needs to be negative. You're thinking of numbers like 1 and 24, those are too far apart. 2 and 12 are too far apart. 6 and 4 are going to be too close. It's got to be -8 and +3 are my factors. You can check because -8 times +3 is -24. -8 plus +3 makes -5. These are my factors, which means my solutions are the values that make either one of these be 0. In this case, the first one would be a +8, and the second one would be a -3. Those are the solutions to the problems. These last two, before I ask you to try, are kind of special cases. These ones are actually the type of factoring that we did a little while back. It was greatest common factor factoring. If you only have two statements, you can't do multiply add. You have to divide out the biggest number that the numbers have in common and the most amount of variables. So we're going to review that real quick. If I look at the 6 and 12, what's the biggest number I can divide out? Well, that's a 6. What about x squared and x? The most amount of x's I could divide out would be a single x. In parentheses, I write what's left behind. 6 times what would make 6? So this have to be a 1x plus what do I have to multiply 6 by to get to 12? There have to be a 2 here. I can't have any more x's because that was only a single x. So here's my two factors. Now I look, red times blue equals 0. What would make the blue one's the easier of the two right off the bat. X would have to be a -2 in this case. What about over here? What number can I multiply 6 by to make 0? And a lot of people say -6, but that's incorrect. 6 times -6 makes 36. That doesn't make 0. I need x to actually equal 0. So 0 and -2 would be your answers. Last one, what if I don't have it equal to 0 again? Well, I make it equal to 0 by subtract 2x from each side. These are not like terms, so I cannot combine them. I just have to write it as 4x minus 2x equals 2x minus 2x is 0. I just moved the 2x over to the other side by subtraction. Then I do the same thing. What's the biggest number I can divide out of 4 and -2? Well, that'd be a 2. What about the x's? I can divide out 2 here and 1 here. Well, I can only divide out 1 from both of them. Behind. 2 divided by, well, 2 times 2 would make 4. So 4 dividing out a 2 would leave a 2. There's an x here because x times x would make x squared. Minus 2 times -1 would make 2x. And now it's factored. You can check because if you distribute back 3, you'll get the left side. And now it's red thing times blue thing equals 0. What would make the blue thing be 0? So I would have 2x minus 1 equals 0. I add 1 over to the other side, then divide by 2. So one of my answers is 1/2. What would I have to multiply 2 by to make 0? Again, mistake people make is telling me -2. That's incorrect. 2 times -2 does not make 0. 2 times 0 makes 0. So whenever you have this greatest common factoring type problem, almost always one of your answers is going to be 0. So there you go. I'm going to have you try one more common type of factoring, one where you have to multiply to make the last part, add up to make the middle part. So solve by factoring first. Factor first and use your factors to find the solutions. So pause the video now, unpause once you've had a chance to try, maybe a minute. Okay, here we go. I need to multiply to make -15, which tells me the numbers need to be opposite in sign. They have to add up to be a 2, so my bigger number needs to be positive, and my two factors are x plus 5 and x minus 3. Those are just the factors, though. I know they multiply to make 0, so one of them has to be 0. The first case, x would be -5 in order to make 0. The second one, x would have to be a 3 in order to make the product be 0. So there's my two solutions. My two solutions are -5 and 3 because my two factors were x plus 5 and x minus 3. And that is it. Thank you very much and have a good day.